Alright, we're going to do two theorems today related to solving polynomial equations called the irrational and the imaginary root theorems. We're going to start out with irrational. So what I have already worked out on the screen for you guys, I just took a quadratic equation, and in this case I used the quadratic formula because you cannot factor the quadratic that's there. So using the quadratic formula, my a value is 1, b is -8, c is 9. So, forgive me, this is just the quadratic formula. So opposite of b would be 8 plus or minus -8 squared minus 4 times 1 times 9 all over 2 times 1. And under the square root, that is going to simplify to be 28. And what I did, sorry for the noise, what I did over here was just write that square root of 28 in simplest radical form. Biggest perfect square that goes into 28 is 4 times 7. So I took the square root of 4, you can remove the 2. And this is what I ended up with. And I just want to show you here, don't touch the radical, but all those numbers are divisible by 2, so that could be reduced. So this is going to be 4 plus or minus, you're not going to see the 1 written in front. 2 divided by 2 is 1. They're just going to write it like this, which is the square root of 7. Okay, so I want to relate this to what we're going to do in this first thing. Anything that is a root or a 0, these would be the zeros of this polynomial. 4 plus the square root of 7, 4 minus the square root of 7. So that's all that it's telling you. That's what's going on here. Irrational conjugates, number pairs of the form a plus the square root of b and a minus the square root of b, where a and b would just represent numbers here. And what the irrational root theorem is going to tell you is if a plus the square root of b is a root or a 0, then automatically a minus the square root of b is also a root. So this is kind of related back to my example, why I wanted to show this to you. If 4 plus the square root of 7 is a root, then automatically, because of that plus or minus we get in the quadratic formula, what we call its conjugate is also a root. So this first example is literally just, if I know this is a given root or a given 0, what else do I know? So if 2 minus the square root of 5 is one of the roots or zeros, then automatically 2 plus the square root of 5 is also an answer. If the square root of 7 is an answer, then automatically its conjugate, which is the negative square root of 7, is also an answer. Sorry, let me back up for 1 second. Irrational just means the number, if you have a square root that's not a perfect square, if you try to take the square root, for example, of 7, it becomes some nasty number that has no pattern and can't be written as a fraction. So that's when we're using the irrational root theorem, is when we don't have something nice under the square root. If you don't have something nice under the square root, that ends up being an irrational number. Okay, another quick example here. Now, when you write a conjugate, so this is -3 plus, this does not change. Just like when we did the quadratic, let me move this formula up here. This is 8 plus or minus the square root, and then 4 plus or minus when we simplified it. So that 4 stays the same. So if you get something like this, the only thing that changes is that symbol in the middle. So this would be -3 plus this, -3 minus this. If this is negative root 10, then positive root 10 would be the other 0. Okay, now the ultimate goal of working through this is going backwards and using the roots to write the polynomial equation. So instead of starting out with the equation, we're going to start out with the answers basically. So 7 is a root. Don't do conjugates with plain numbers. If positive square root of 6 is a root, then automatically negative square root of 6 is a root. And so what we're going to do is we're going to set up the linear factors. So x value of 7 would correspond to the linear factor of x minus 7. Okay, if we have a positive square root of 6, the little factor would look like this, x minus the square root of 6, and then negative would be x plus the square root of 6. Now, these are a little bit tricky, and what we are actually going to do here is FOIL. So the easiest way I can tell you to do this, multiply together the factors that have the conjugates first. All the irrational parts, all the radicals are going to end up canceling out. So I'm going to focus right here. So just keep this x minus 7 for a second. So x times x squared, I'm just doing a FOIL, x times the square root of 6 would be plus x radical 6. Now, because your conjugates here, you're going to turn around and that's going to cancel. So negative square root of 6 times x would be a negative x radical 6. And negative root 6 times negative times positive is going to be negative. Now, both of these are under a square root. 6 times 6 is 36. So I get x squared. These cancel. And then the square root of 36 is actually 6. So I'm going to just simplify that. And we're not quite done because we had 7 as a 0 as well. So to get the final answer here, we're going to need to FOIL this out. So x times x squared is going to give you x cubed. X times negative 6 gives you negative 6x. Negative 7 times x squared is negative 7x squared. And negative 7 times 6 is going to turn into positive 42. Now, the only thing I would do here real quick is just rewrite this in standard form. So that just means your powers of x go in order. So I need the x squared term to come after the x cubed term. So I'm just switching these two guys' spaces. So this is in standard form. All right, now I've got another little example at the bottom. So this is not part of example 2. This is going to illustrate our next concept, which is going to be imaginary root theorem. And this is very similar. So I just got an example. This is a quadratic equation that can't be factored, so I'm solving it using the quadratic formula. A is 1, B is negative 6, and C is 13. So I just plugged this in, did the first couple steps of the quadratic formula. When I get here, the 16 is actually a perfect square in imaginary land. We just take care of that with an I, so 6 plus or minus 4i over 2, and everything here is divisible by 2, and so this can be further reduced to 3 plus or minus 2i. Now, you'll notice this is two different numbers, 3 plus 2i and 3 minus 2i. Those are the two roots, the two zeros, the two answers, however you want to say it, to this question. These are called complex conjugates because they've got an I in them. So irrational has a radical of some kind, and if we have complex, which we're going to talk about as soon as I flip the page over, complex have an I in them. So this is extremely similar to what we just did. It's just I's instead of radicals. So complex conjugates, you have A plus BI and A minus BI. And the imaginary root theorem is going to say if A plus BI is a root or a 0 or an answer, then A minus BI is also a root. So if you have one, you automatically have the other. So just a couple examples. If I have 2 plus 9i, then automatically 2 minus 9i. If I have negative 7i, I automatically also have positive 7i. Again, the number in front, if it ends up being negative, that doesn't change. The conjugate just changes the symbol in the middle. So negative 6 minus 5i, negative 6 plus 5i, positive 4i's conjugate would be negative 4i. So those are additional roots if we're given those. So here we're going to write some polynomial equations, kind of like I did on the front. These are a little bit trickier, especially if you have a number minus or plus, and either imaginary or like we're going to practice over here if you have, this is a combination, this has irrational and imaginary roots. So first thing I'm going to do, I'm going to automatically write down the conjugate for each of these imaginary numbers for my imaginary root theorem, and I'm just going to focus on this. So let me start here. So I'm going to have an x minus 6i and an x plus 6i as my linear factor. Now, these are trickier. So here's how this works. Normally, like if I have a positive 6, right, we would write x minus 6 for the linear factor. If we have a negative, we write a plus. these both start with a positive 1, so I'm going to write a minus. And what you want to do is, if this has a couple parts, go ahead and put those in parentheses. And both of these are positive 1, so I'm going to start both off with a minus. And you can see these linear factors are different because we've got the conjugates there. Now, here's what I would tell you to do. I'm just going to simplify this a little bit just to drop the parentheses, and that's going to distribute a negative. So this is going to be minus 1 plus 4i, because I got a minus a negative, and this is going to be minus 1 minus 4i. Okay? And I'm just going to bring down the two other factors. Okay, now here's my recommendation. Always multiply together the conjugates. So I'm going to start here, and I'll just use some, like my little highlighter here. I'm going to FOIL this. Okay, and we're eventually going to have to multiply this all together. So I've got 4 different x's across the line here, so this is going to end up as x to the 4th. So I'm going to have x squared. Now we'll have plus 6ix. Then we'll turn around and get minus 6ix. And then the last term, negative 6 times negative 6 is negative 36. I times I is I squared. And just a little note for these, if you remember when we did imaginary numbers, for the definition of I, if you get I squared, that is equal to negative 1. So these are both gone. This is x squared minus 36 times negative 1. So this ultimately simplifies down to x squared plus 36. Okay, now I need to multiply these together. Here's what I would recommend. It's totally up to you. It's like a triple distributive property if you want to do a FOIL type thing. I don't know why, but I have always drawn boxes for these. It just helps me organize with all the different terms you have to deal with. But I am going to multiply this with a box. So I have x minus 1, one of these is plus 4i, x minus 1, and then minus 4i. I'm going to go through here. X times x is x squared. X times negative 1 is going to be negative x. Here you're going to get 4ix. And then I'm going to multiply everybody by negative 1. So negative x, negative 1 times negative 1 is positive 1. And then this is minus 4i. Minus 4ix. These two negatives are going to cancel, so I'm going to get plus 4i. And down here, negative 4 times negative 4 is negative 16. I times I is I squared. So this box here is turning into negative 16 times negative 1, which ultimately is going to give me 16. Okay, now let me go back here. These cancel. These cancel. These do not cancel, so be real careful with that. You have minus x, so that's minus 2x. And then here I have the 16 and the 1. So when it's all said and done, this is going to be x squared, 1, 2, minus 2x, 1 and 16, and 17. Oops, sorry, I'm not on the screen. Okay, now ultimately to get our answer, I need to multiply these two. I know this problem is really long. Totally up to you if you want to make yourself a box or if you want to just multiply it. I'm just going to go ahead and make a box here. So I've got 2 terms there, and I've got 3 terms here. So I'm going to do x squared plus 36. We're trying to put this in standard form, which is why we got to multiply it all out. This is going to become x to the 4th. Again, sorry, I'm not on the screen. This will be 36x squared. This will be negative 2x squared. Negative 2 times 36, this is going to be negative 72x. This will be 17x squared. Forgive me, let me back up. This one should have been x cubed. Let me check. The rest of these are okay. This is an x. These are okay. And then 17 times 36, I got to grab my calculator for that. 612. Okay, now all I got to do here is go ahead and combine any like terms if I can. In this case, I've got just the x to the 4th. There's only one term with an x cubed, so minus 2x cubed. Now, these are both x squareds, so we're going to have to do 36 and 17 added together. So this is going to be 53x squareds. There's only one term with an x and only one plain number. So that was really long, but that is ultimately the answer, the polynomial that has those zeros. Okay, and I ran out of space on my paper because I was writing too big, but there was another problem, and this is a combination. So this has an irrational root, which has a conjugate, and an imaginary root, and so it also has a conjugate. So this has 4 different answers, and we're going to convert this into a polynomial. So again, these both start with a positive. So when I write the linear factor, I'm going to start with a negative, and then I just put, if it has 2 terms, parentheses. And I'll simplify this before I start multiplying. Both of these are positive 3, so this is going to start with a minus. And it doesn't matter the order that you do these in. I usually put the conjugate linear factors together, like I put these two together, and I would always, always, always recommend multiplying the conjugates together because all the irrational or imaginary parts will cancel out and go from there. Now, before I start this problem, I'm going to simplify and drop some of these parentheses. So it's just going to change some signs. So this is going to be x minus 8 minus radical 5, x minus 8 plus radical 5, so just one of each. And then this is going to be x minus 3 plus I, x minus 3 minus I. Okay, I'm going to put these two together first. So again, I kind of like to draw a box when I do these problems because it just helps me organize a little bit better. Alright, so I have an x minus 8 minus radical 5. I have an x minus 8 plus radical 5. X squared, this is minus 8x minus x radical 5. This is minus 8x. Negative 8 times negative 8 is positive 64 there in the middle. Negative 8, negative radical 5, so this will be positive 8 radical 5. This is positive x radical 5. This is negative 8 radical 5. Now down here in the corner, negative times a positive, this is negative square root of 25. So this is negative, and then the square root of 25 is 5. Now let me back up here. All the irrational parts should cancel out. So these all cancel each other. And what I have an x squared, minus 8, so minus 16x. And then 64 minus 5, literally just going to subtract those numbers, that's 59. Okay, now I'm going to multiply these two together because we're just trying to get rid of all the imaginary and irrational parts. And then what we'll be left with is kind of a little bit trickier, but it's just a multiplication question is what we're going to be left with. Alright, so I've got x minus 3 plus I, x minus 3 minus I. So again, x squared, I'm just going to go right down the line, minus 3x, and then I times x. Negative 3x, just right down the column here, this will be positive 9 minus 3i. Then negative I, right down the column. Negative ix, negative times negative will be positive 3i. Now, down here in the corner, I have I times negative I, so that's negative I squared, which is negative 1. So this is actually just the number 1 down here in the corner. All the imaginary parts should cancel out if you've done this properly. And you'll notice if you set up this box, these are always, like it's these 4 boxes that always cancel each other out. They're always in the same spot. And the leftover, I've got x squared minus 3, so minus 6, and 9 plus 1 is plus 10. Okay, I know this is getting long, but ultimately to get the final answer, I need to multiply these two together. So I am going to draw one more box. these a little bit. Okay, so I'm going to go 3 by 3 here. So I have x squared minus 16x plus 59. I have x squared minus 6x and then plus 10. This is, whoops, x to the 4th. This is negative 16x to the 3rd. This is 59x squared. Now, nothing should cancel here, so we're going to have to combine some like terms as we go through. This will be negative 6x cubed. Let me grab my calculator. 6 times 16, the two negatives will cancel out, so this will be 96x squared. And then I'm going to do 59 times negative 6. This is a big number, negative 354x. This will be 10x squared. 10 times negative 16 is just negative 160. And 10 times 59 is going to be, oh my gosh, guys, I'm sorry, I'm off the screen, 590. Okay, my apologies. Let me give you a second to look at that if it wasn't on the screen. We're going to combine like terms. So I have x to the 4th. And let me just circle these. So here are my x to the 3rds. They're both negative, so this is going to be negative 22 x to the 3rd. Here's all my x squareds. So I'm just going to grab my calculator. I got 59. Oops. Sorry, we got 59, 96, and 10. So when I added those all up, I got 165x squared. Okay, now I got negative 354 and negative 160 for my x's, so this is kind of a big number. 514x, and then plus 590, nothing else to combine that with. I know that's really long, but that's ultimately what we're looking for, the polynomial with those given roots.